Welcome to Study Loop.
In this question we have given a rod of length L and it is pivoted at one end and it is rotated with a uniform angular velocity in a horizontal plane, and T1 T2 is the tensions at the point L by 4 and 3L by 4 away from the pivot, and then we have to find the relation between these two tension. So we can say that at L by 4 from the pivoted end we have given tension, that is T1 is equal to, this is centrifugal force on the rod behind this point, that is 3L by 4 length. So this is given by, that is m dash into, this is omega square into r. So we can say this will equals to m by L into 3L by 4 into omega square into, this is L by 4 plus 3L by 8, because r is the distance of center of mass. So from here we can say that this will comes out to be as T1 is equal to 15 by 32 m omega square into L. This is the tension T1. Now we can say that tension T2 is given by, that is centrifugal force on the rod behind this part, that is behind this point, and this is equals to length of L by 4. So this will comes out to be, that is m dash into omega square r. So m dash is the mass of the 1/4 of the length, so this is m by L into L by 4 omega square, and this is equals to 3L by 4 plus L by 8. So this will comes out to be 7 by 32 m omega square L. This is our tension T2. As we can say that from T1 and T2, that T1 is greater than T2. So for that, this is our answer. For that, option A is the correct choice. Thank you.